Okay, yeah, sorry. I was on mute. Seems you're live. Can everyone hear me across platforms? How are you all? Um, I'm Mudit from DeFi. A lot of our community members who have been attending these sessions would know me now. I'm one of the founding members of DeFi. We are a global community of AI. And what we do is we bring together some of the best data scientists out there. Uh, and we build a community out of it, which can educate and build AI for all. If you are new to DeFi, you can probably visit our website. You will find a ton of free courses, boot camps, live sessions, and all that we do on a regular basis. That's a very quick and short intro of DeFi. Um, if you can hear me across platforms, let me just go and check if you're perfectly audible. And that will also help me to ensure that nobody is missing out on the learning opportunity. Just give me a moment. I'm checking. Um, yes. By the way, if you can hear me, it will be great if you can comment something like hi or something similar. That will make things a bit easier. Hmm. Yep. I think we are live across platforms. Just want to confirm on LinkedIn. Are we clearly audible on LinkedIn? Yes, yes, you're audible there as well. Great. Oh, there are eight. Oh, there's a good number of people watching us as well. Okay, great. Good to see you all. Sorry for keeping you waiting in this entire process of verifying if you're live across platforms. How are you all doing? Um, a big hi to anyone who's joining live and the ones who are watching it later as well. It's an interesting thing that we have noticed lately that a lot of community members they watch it live. That's definitely the essence of these discussions where we get to interact live with the leaders that we host on a weekly basis. Um, Generally, these are contributors who are putting a ton of effort to make sure that the AI community gets to learn a particular concept to its depth, and that's a great opportunity from learning perspective, and which is where joining live makes sense. But at the same time, there are many community members from various geographies who kind of struggle to watch it live. So if you are one of those, I welcome you to this particular session. Let me give a quick intro of myself. I did that very quickly in the beginning. Let me do that again for the viewers who have joined now. So I'm Mudit. I'm one of the founding members of DeFi. We are a Belgium-based startup, and more so, we are a global community of AI. We started with the vision of democratizing AI education for the world, and we did that basically by bringing together some of the best contributors out there who are willing to join hands with us and help in making AI education accessible to everyone. So that's where we started. We did a few boot camps, and since then, we are impacting people from more than 150 plus countries and have a 100K plus community on our platform. That's a brief about DeFi. If in case you aren't aware of what we do, you can probably visit defi.tech, where you will find a ton of resources. Most especially, if you can just check out our LinkedIn prior to this or any other platform that you're watching from, you can probably get to see the boot camps that we're launching in the near future. We're starting off with 7 mini boot camps across a bunch of topics. Starting from, if you're a beginner, you can take up something like Python basics. On an advanced level, you will find things like I think unsupervised learning, explainable AI, and more things around it. Okay, so depending on your interest, you can join any particular boot camp. As shared, all of our resources are 100% free, and you can join them. You can learn from them. You can grow with the community and try to give back as and when possible. Now, without any further ado, let me dive right into the session. So today we are hosting Venkatesh, and the goal of the session is to discuss about vision-based brand analytics. Okay, now what is this? Basically, the idea is pretty simple, and I wouldn't dive a lot into it because I'm pretty sure Venkatesh, who's on the backstage, he can do it at least 10 times better than me. But to give a quick context, it's all about on today's date, the visual content, the visual data that is out there is growing at an enormous pace. We can include both images and videos in it, and given that, we can make a lot of predictions and a lot of analytics that can help in making better decisions for businesses out there. Okay, vision. Talking about Venkatesh specifically, he is a principal data scientist with more than 10 plus years of experience in the industry. He has a special expertise in deploying cloud on the edge, sorry, AI on the edge, and in visual AI, embedded AI, engineering analytics, and all. Um, Currently, he is also working as a solutions consultant at Sahaj Software, where he leads the team to build purpose driven AI, and data-led solutions, focusing mostly on computer vision and deep learning solutions. So that's a brief about Venkatesh. Now let me just quickly loop him in for you all to directly interact with him. So yeah, hey, hi Venkatesh.
Hey, hi, Mudit. Uh, you're able to hear me?
Yes, perfectly.
Yeah, yeah.
Thank you so much for being here, Venkatesh.
Thanks for hosting me. Actually, I really when I had a conversation with before starting with the session, when I had a conversation with Mudit, actually, I didn't know much about DeFi. I mean, I was aware of the name and the boot camps and the courses that you people do, but not the motto vision behind your platform as such. So I really liked the vision and. I thought I can be part of this in whatever way possible. So as part of that, thanks for hosting me. So yeah, I think you're able to see my screen.
No, I think I'll just add that to the stream. I
Okay,
think yeah, we can dive right into the session. And again,
sure.
thank you for that kind appreciation. It means a lot, to be honest. I'm not good at thanking, expressing my gratitude in these contexts, but genuinely, thanks a lot for that kind words. Um, I'm adding your presentation to the screen and going to the
Mm,
background. It is
okay,
visible to the learner, so you can just dive right into it.
okay. It is full screen, I believe now. Yeah.
Yes, yes, it is.
Okay, okay. So yeah, I think Mudit gave a very good introduction of the session as well. So today we are going to talk about vision-based brand analytics. So I have spent close to 18 months of time working on this, building this platform, and 2 to 3 different use cases around this platform as well. So we will start from the scratch, like what is the background of background and need for the vision-based brand analytics, and what is the opportunity and potential, why why is it needed in the first place, and what all are the different use cases or the applications once you are able to do the brand analytics, where all you can apply it, right? So first, to begin with, to understand the opportunity. So once we look at the multimedia data on day-to-day basis, it is mainly available in 3 different ways, right? One is text data, another one is visual data, which is image and video, and third one is audio or speech data. So out of all this, when we look at the in terms of quantity, right? If you look at various platforms, you take a social media platform, a broadcasting platform, considering the evolvement of the engagement of the users across the social media, availability of the internet, and the way technology has evolved, the when it comes to the creation and consumption of the multimedia data, for the image and video, it is considerably lot more higher as well, right? And also it opens up to the various possibilities. Once you have the image data, video data from a given channel or a platform, then there are n number of ways that you can do with that data. And when it comes to the potential, it's been quite some time, right from the AlexNet back in 2012. Now it is 2022, and the particularly when we see the evolution of the various deep learning frameworks, all the way from Theano, Cafe, we are using TensorFlow, PyTorch, and we are able to do distributed training of the models. And we have not just the CPU, GPU, you can train the models on the TPU as well. You can really handle the during the training large amount of data. In terms of the storage memory, lot of improvement has happened. So overall, in terms of potential that entire machine learning or the data science offers us, we are at a considerably lot more better space than what we were earlier, right? So with this, we will look at whether we can do something with the image and video data that is available to us on daily basis, right? And when we look at the opportunity in terms of the market, the survey says that it is 2022 now, it is like already 40 billion USD market. I'm talking about the image and video data related industry, what all we can do. And the growth rate annually, it is like stands at 19.5 percentage. And when it comes to the opportunity or the way we can adapt it across the industry, more or less you can say it can be mostly applied across each and every industry. And some of the industries that I have mentioned here, they see the heavy adoption, especially if you look at retail, the e-commerce platforms, and the next gen superstores that we are thinking about that come under retail, and even the banking sector, right? What all we can do with, say, for example, if we want to analyze the credit history of the customer, we have the access to the various financial documents, loan documents, what all we can do with it. And even the automotive sector, right? There are various like use cases that one can do. And of course, there is a medical imaging use case when it comes to healthcare and the defense. So, including marketing and insurance. Now, idea here is, I work for a Sahaj software. We have built a solution accelerator called Wink. So this solution accelerator is mainly as a, solution use case. It is built around the to do the job of vision-based brand analytics. So I'll brief about this so that in the context of this particular session, it helps us to understand from where we started actually when we thought of building something like brand analytics, from where we started. Then of course I'll just brief about this and we'll talk about the core part of it, what constitutes the brand analytics and its components and its use cases as well, right? So here the opportunities, we already spoke about the image and access to the image and video data on daily basis. Now if we want to look at from the brand presence or the brand visibility sense, right? Let us take an example of a football match. Let us say there is a live football match going on, and brand can be present in various ways, right? For example, player is wearing a Nike jersey, so that is the like brand presence. And maybe he is wearing Adidas shoes, and there is a hoarding in the background that has the advertisement by Red Bull brand, and maybe there is a digital advertisement in the background that is going on during the match. So there are various ways in which the brand can be present, right? And let us say another example, for example, F1 racing car event, and maybe the F1 car racer, he is wearing a suit that has the sponsorship by various different brands, and his car will be having the like logos by the different brands as well. So in this way, if we look at some of these use cases, the brand can be present in various different ways. So if we look at let us consider this as a pure computer vision problem statement, right? So how can we identify the brand, right? It can be identified in two ways. One, the presence of logo, and in some cases, along with the logo, the name is also present separately, or the name itself is part of the logo. For example, Adidas, there is a logo plus name, right? And in some cases, maybe just the logo is present. So based on the logo, you identify, okay, there is a particular product from a given brand that is present, or this particular image or the content belongs to this given brand. That's how we identify, right? So just to brief, Wink is nothing but whatever we have built. It is a end-to-end highly optimized custom object detection framework, and it is more of a solution accelerator, right? So it acts as a solution accelerator for any given visual AI projects, and it is mainly designed uh, to build the brand analytics platforms. So what I mean by that is our this platform Wink, it comes with various modules and the components. For example, pre-processing module, and then there is a training pipeline, then there is an inference pipeline, post-processing module, and also the analytics engine. So it has some modules and components that are like over a period of time built with all the experience and made configurable and flexible, and that cater to the idea of brand analytics. Okay, this I think we can, in the interest of time, maybe we can take a look at this later on, because I want to cover more of the core part of the brand analytics. Okay, so when it comes to use cases, right, we are talking about, like, let us say I do the logo detection. I find out that there is a presence for a given brand. What all I can do with it, right? One thing is I can identify the presence of brand across the image and video, which means I can find out whether how many frames has the particular, of course we will talk in detail with the examples, but just before we begin, I'm just highlighting different use cases. So we can identify where the logo is present. Is it present in the background or foreground? And across the, let us say, football match happens for 90 minutes, right? In that, I want to know what was the duration corresponding to the presence of the Nike logo, right? Was it present for the 2 minutes, 3 minutes, 10 minutes? It could be like anything, right? The logo could be present on the shoe, like I said, jersey, or some advertisement hoarding as well. And with this, we can also do the comparative brand analysis, right? I want to know, like, let us say there is Nike and Adidas logo. I want to compare which logo fared well. What I mean by that is, say, for example, the size of the given logo out of these two, which one was better? And in terms of exposure, the duration, which was out of these two logos, which was better than the other one? It helps me to understand, like, when we people plan for the sponsorship deals or the campaigns, whatever they invested, whether they are getting the right amount of ROI or not. So it helps with those kind of things. And another use case is, of course, the counterfeit brand logo detection. What I mean by that is, brands want to understand whether their logo is being used in a wrong way, or the other way around, whether there are any duplicate products with different companies where the logo looks similar to that of the original company, right? So we can do the template matching of the logos and find out whether the whatever logo we detect, or the brand presence we detect in that content, whether it is from genuine and original brand, or it belongs to the, it is not a original one. That's what we can find out as part of this use case. So as I said, the before, the brand analytics is like the post processing of the logo detection, right? So the main way we go about it is, like, we do the logo detection. Then on top of that, what all we can do is the analytics part of it. So first we'll talk about the logo detection part. So this is a sample of at the early stage when we started with the idea of this brand analytics. This was the idea. We took example of the Nike and Red Bull logo, and we thought we will build the logo detector and then do some analytics on top of that. Right. So if you look at this diagram, basically image augmentation is definitely needed, just like all other deep learning and computer vision based use cases and projects. um, because we had, of course, we had close to 3000 hand labeled images, but as you know, like, no amount of the image is always enough for the data science or machine learning projects. So of course, to ensure the model is more generalized and not overfit, we have to like tinker with the data or the images and do the image augmentation and ensure that we have the good number of images to be able to train the model. And for the logo detection is nothing but a object detection task, right? If you look, I mean, of course, there are different ways to identify the logos. You can do the object detection, you can do the segmentation as well, if we are talking about computer vision task. And again, within the object detection, there are like a couple of different ways to go about it. So first I will talk about the typical object detection method. Then I will talk about its challenges and why we adopted the other method. Okay, so this method is like, as you understand, you can make use of the any open source data sets, such as say, for example, ImageNet data set or Coco data set. You can build the you can train the object detector model. And once you have the hand labeled images from the given logos for which you want to build the logo detector model, you can do the transfer learning for that model. And to do this task, right, as an object detector or the convolutional neural network, you can use the faster RCNN, you can use something like YOLO. You have the YOLO V5, V6 nowadays. And with that, you will be able to get the both, right, region boundary box, meaning the coordinates of the logo, and what logo is it, basically classification. So with these two, you will know, like, later on what all you can do with it. because you know the placement or the position where the logo is present, plus what kind of logo or which brand it belongs to. Okay, so when it comes to image augmentation, it is always better to have the so we have our own augmentation engine. The reason being, of course, as you all know, augmentation is definitely needed for all the like computer vision or deep learning projects for sure. But again, in that, right, it is not universal in the sense, there are like, for example, there is a rotation, there is shifting, there is a zoom in, zoom out, crop in. These all methods, right? There is no need to, like, all the methods have to be applied for all the use cases, right? So for example, some of the use case, that there is no need to rotate the object in the first place. In that case, applying that particular method becomes redundant. So what one would do is have the augmentation module and make it configurable, so that for a given again, like in the case of brand analytics, depending on the use cases, the augmentation methods that one wants to apply might vary. Okay, so some of the methods, of course, we applied is like the rotation, shifting, zoom in, zoom out, which is like, the object cropping and all. So for another interesting use case, I'll talk about, for example, let us say someone wants to do the anomaly detection in case of logos, right? Meaning they want to find out whether the logo is from their brand or it is some other anomalous logo, right? In that case, you have to be very careful. It is also important to find out the original color also, because some brands are strict with their logo color, right? So if you make your model to detect the given logo across the different colors, then it will not identify that, right? So this is just an example that I gave. So considering this, you have to first analyze the problem statement and know in what all ways the given data or the image or the, like, logo or object in this case can be present. Accordingly, you apply the various augmentation methods. So once we were able to train the object detection module, which is a logo detector in this case, and the typical results would look something like this, right? So as you know, it will come with a confidence score from 0 to 100. So in this case, let us say this image has a F1 car with a Red Bull logo, big Red Bull logo on top of it, and the confidence was something like 99%. It also has, interestingly, one more output here, which says 0.55, which is a prominence score. So I will talk about what is a prominence score. It is one of the byproduct of our analytics engine, and this is another sample output. Uh, and yeah, this is the output for the Nike logo, because I spoke about we started with the Nike and Red Bull. The other one was for the Red Bull, and this is for the Nike. And here the prominence score is the 44% or 0.44. Okay. Yeah. So this is the example where I'm going to just briefly play this video just to show you the main idea behind. Yeah. So now we are able to do the logo detection. So once we are able to do the logo detection, and let us say we have the, in a given image or a frame, we know where all a given brand or logo is present, its coordinates, and which brand or the class it belongs to. With that, what all we can do? So of course, based on the use cases, there are like various parameters or the components of the analytics that you may have to compute or they perform. But I'm going to talk about 4 to 5 different components or the parameters here in the context of one of the use case that I'm going to talk in detail. And then later on, we'll talk about other use cases and corresponding components that we may need. Okay, so let us say our objective is to understand the presence of the brand or the visibility of the brand in the event, like let us say football match or the F1 car racing event, right? So what all is needed to be able to give what the client is looking for, or the, like, if we look from the business use case point of view. So what all we want to know, right? So one thing is we want to understand across the entire event, what I mean by the across the entire video, where all my brand appears, right? And where it appears, in the sense, was it in the foreground or background? Meaning, if it is on the player's jersey, you can consider it as it is in the foreground. If it is a part of, let us say, someone from the audience is holding a board and it is there, then it is part of the background. But if the camera focus is on that, then it becomes part of the foreground. So it is important to know where is it present at a given point of time, and then how it fares compared to the competitor brand, right? So be it in terms of size, be it in terms of clarity, because I spoke about the possibility associated with the noise, blurriness, and all. So there is a possibility, even if the brand is present, was it clearly visible to the user or not? And was it part of the bigger picture? Meaning, if we look at the entire frame, how big was my logo, or like how prominent was my logo visible? So these all things do matter. So based on that, some of the parameters that can be computed here are like, one is visibility, which gives you a percentage of exposure. Meaning, out of my entire logo, what percentage, or like how what portion of my logo is visible, that can be computed based on the template matching, right? And another one is size. So compared to the entire aspect ratio, or the entire size of the frame or the image, what is the size of my brand or the logo in this case, right? The placement is the presence, where it is present. Is it in the background or a foreground, or which quadrant is it present, if someone is interested to know that. And because if it is like, let us say, golf or something like a tennis match, it is, even if it is like, let us say, the sponsor is Kia, it is important to know, because it can be present in various different ways, right? When it is broadcasted, they want to know where their brand was visible. Was it part of the court where the players were playing, or was it part of the place where they rest? Things like that, right? So that's where placement is important. Prominence is more about um, the how highlighted your brand or logo looks compared to the surrounding pixels. So what I mean by that is, like, let us say, for example, if you are wearing a white, sorry, a black jersey, and your logo is white, then it is prominent, it is easy to spot, right? Compared to, like, let us say, a blue logo on top of red black jersey, right? So prominence is more about the contrast, or the how prominent your logo looks compared to the surrounding pixels of the entire frame. Okay. Spotlight is more to do with like I was talking about competitor analysis. It is like the portion during the event or the entire video where the given brand is present compared to the competitor brand or some other brand. Okay, we'll talk about these use cases in detail. So what I'm going to do is, I'm going to talk a bit detail about the prominence score, so that we understand about the at least one component of the analytics engine in detail, and the rest of the components, like I spoke about, size, placement, spotlight, and all, they will follow the similar path to give you the idea. So like I was saying, prominence score is basically more to do with, compared to, I will show in the form of the actual image or the output. It is more to do with compared to the background pixels or the surrounding pixels, how highlighted your logo looks, or in terms of contrast, right? So it is mathematically computed score, which ranges between 0 to 1. You can always scale it to vary between 0 to 100 as well. And what we used for the prominence score is basically, of course, you know about, if we are talking about taking two different feature maps or the vectors, and you want to find out the similarity or the difference between them, some of the metric you apply is Euclidean distance, cosine similarity, metric like that, right? So for us, what worked really well was Hellinger's distance. The reason being, it is this particular probability distribution metric, right, where you give the two different vectors, and it finds out mm, how similar they are, like, meaning in this case, how symmetrical they are is what it finds out, right? So if we take a inverse of that, then it gives you, like, score between 0 to 1, which means if it is 1, then it is definitely more prominent. meaning compared to the background pixels, the distance is like, really high on the higher side. That's why when you take the inverse and you scale it up, then you whatever value you get, it corresponds to the higher contrast between the logo and its background pixels. Okay. And yeah, so this particular image is from F1 car racing video that I was showing you earlier. So in this case, this image has the presence of logo at three different instances: one in the center, one in the on the left side, and one on the right side. So understandably, it is given that we can tell definitely left and right one will be more prominent than the center one, because of the size. And even if you look at the image and suddenly the left and right one are the one that will like more visible or prominent to you, right? So this clearly says that the prominence score for these three are for the left one you can see that it is 75% or 0.75, right one it is 81% or 0.81, and for the middle one it is 0.43. So another idea here is, let us say you want to find out or the compute the prominence score across the entire video, right? In that case, what you do is, to be able to do that, you want to find out the prominence score for the entire frame first, so that you can average it across the video and find out the score or the value corresponding to the entire video. To be able to do that, you can always average it out. So in this case, if I have to tell the from this particular instance or the frame, the prominence score will be the average of these three values: 75%, 81%, and 43%, right? And if we look at the results of the analytics engine, right? For example, earlier I showed you one video from the F1 car racing event, and towards the end of the video, if I want to look at some of the analytics components or the parameters, how they the values look like, right? This is just for the sample. Say for example, it says prominence is 0.63, which means across the entire video. So let us say it is a 8 or 9 minute video. There are like 13 to 14,000 frames. Across that, wherever the logo is present, the average prominence score is this. We can always plot a graph of prominence scores that varies across the basically on the x-axis. For example, you can something like this. On the x-axis, you can take the number of the frames or the timeline. On the y-axis, you have the prominence score. So this gives you idea, like you can see that, okay, somewhere around say 50th frame, or the sorry, in this case 50th seconds, the logo or the my presence of my brand is more prominent, right? Versus it is lower between somewhere around 36 or 37 seconds, it's really low. That's what we can do. We can always do all these visualization dashboards and give them accordingly. And if we look at other scores, right? For example, footprint, brand footprint. What I mean by that is, so let us say there are 13 to 14,000 frames. Out of that, how many frames had the logo from my brand? That's what customer is interested to know. So that is called brand footprint. And the exposure time is if you translate it to the time. Basically, you have the frames per second and you divide the footprint by frames per second, you get 34 seconds. What it means is, let us say across 2.5 to 3 minute video, uh, across 34 seconds, my brand was visible, or that particular logo was visible. That's what it means. And the clarity or the quality of the logo is the another factor or the parameter here, which means basically what it does is, there are various ways to compute this as well. The brisk is one of the algorithm from OpenCV that one can use. Just like prominence score, we can compute this score to be between 0 to 1 or 0 to 100 as per our convenience. So basically it finds out the this is more like a resolution, right? In case of, if you are seeing a YouTube video, you might have observed 720p, 1080p, something like this kind of resolution will have a lot more better clarity than something like 240p or 480p, for the obvious reasons. So in case of logo, for a given content or the video, if I want to understand what was the clarity of my logo, right? Because by after doing the logo detection, definitely we have the coordinates of that particular logo. We can always crop it out and take that and find out whether is there any noise present in that, or is there because we can always find out the given image has any blurriness or not. So by performing these type of tasks, because it will be like you have to go with the ensemble approach here, because one is finding out the blurriness, another one is finding out whether there is any form of noise. For example, white noise, there are different noises present, and you have to average out all these scores and then give the weighted score to tell how the clarity or the quality of that particular logo looks like. Then they will work on that, right? For example, even if like let us say their brand or the logo is present in uh, various ways or various places, if they find out that the place wherever it is present, due to some reason it is not getting the enough clarity or the quality where the viewer can easily spot it or see it, then they will it really helps them to plan the things in future accordingly. So that is the whole intent behind some of these things, right? And if we look at the results, so these are like the logo detector model, whatever we trained, these are the sample results that we got. We had a very challenging data set, which had a really unseen data, not the part of the any training set or the during the training whatever validation set we used. These images were not from that. It was really a challenging data set with all the blurriness, noise, and the various edge cases. So we were able to score around 85 to 90% range of precision and recall on this. And this is the combined score. If you want to see, the this one is more for the left one is for the Nike, right one is for the Red Bull. And the reason why I'm showing this is, um, if you use any typical or the traditional object detector, something like YOLO or Faster or CNN, and if you perform the good annotation and you have the because there aren't, for all the brands or the logos you want to look at, there aren't too many open source data sets. Even if they are present, only images are present, you will have to go with the hand labeling. And of course there are tools to do it, but it involves some manual effort is what I mean by that. So considering that, this is the kind of the result that one can get, right? So the problem with this particular approach is, if you want to basically scale it to, let us say tomorrow on daily basis, weekly basis, you want to onboard different brands, different logos and all, then it is time consuming. Every time you have to annotate the images and train the model, and then only you will be able to perform the inference. That is the challenge. That's why there is another approach called one shot detection that I'm going to talk about next. And if we compare our results with something like, let us say someone might ask, there are like generic object detection APIs, right? Like, for example, there is one from Azure, there is one from AWS, you have Google Vision API and all. These are really good. That's why you will see like false positive is really zero, but these are generic solutions, right? These don't cater to the purpose built business use cases that you want to solve or you are thinking to solve, right? So considering that, because it is not just about the object detection here. We are talking about pre-processing, some post-processing. Once you are able to do the logo detection, what all post-processing approaches you want to apply, and then the various analytics components and all. So considering that, the generic using the generic object detection, like might not be very efficient in terms of the performance. That is the conclusion from this particular results. So this is the another approach that I was talking about. So the advantage with the one shot detection is, this is a template matching approach, where basically during the training what you do is, you take a company, for example, let us say you take a company A's logo, which is called anchor, in the context of, because we use the convolutional encoders here for this kind of task. And to train, we have to use the triplet loss. And you have the logo, let us say for example Nike logo, and then as a positive you give the image with the Nike's logo, and as a negative you give the image with some other logo. It can be anything else apart from the Nike. So that, sorry, here you are basically teaching or making the model learn to embed the features, right? You can definitely use for example object detector or the CNN, such as YOLO or faster RCNN or any other state of the art model for that matter, to be able to get the once the because the first task here is, once the image is there, to begin with, you want to find out all the regions or the objects, right? Object detection is what I'm talking about, without classifying, because I'm not interested to know which class it belongs to, but I want to detect which all logos are present in the image. That we can make the model learn, and then once you get the coordinates or the ROI around the different logos, then what one can do is you get the feature embeddings or the feature vector, right? Then you can during the training process, you can always perform the like global average pooling, and you will get the single anchor vector, right? So the idea is, once you train the model in this way, and during the inference, then you will be able to use the logo of your choice, and then whatever anchor vector you get out of it, you can build something like the idea here is you can build something like a reference database, basically, because you have the models trained that are good at finding the embeddings, and you have the models trained that are good at doing the object detection, or in this context, logo detection, without classifying which particular brand or it belongs to, right? Once you are able to do that, during the inference, you can whatever logo you are interested, or the brand you are interested, you can build the reference database. And then during the testing, what you can do is you just give the image of your choice, and it does two tasks, right? It first it does the detection, where it finds out the coordinates of the logo where it is present, and then it does the template matching, which means it converts it into feature vector, and it matches with the reference database that we would have already built. And if there is a match, it says where is the match, means with which brand there was a match. That gives you the output class. So in this way, the onboarding of the new logos will be really faster compared to the other typical object detection approach that we spoke about earlier. Okay, so when it comes to, I'll brief bit about the architecture. So if you want to build, the same thing is applicable, I mean, this is the Wink architecture, but same thing is applicable if you want to build any visual AI solution accelerator, or in this use case, like in this context, let us say you want to build so brand analytics engine. Then of course, because the logo detector is the core part of it, and pre-processing module, post-processing module, and analytics engine are the heart of the entire analytics part of it. But to be able to deploy it somewhere, be it on the edge or cloud, and to be able to productionize it, right? Then of course you will have to do the model versioning and data versioning using some tools like a platform like DVC, MLflow, and for the containerization, one can always use something like Kubernetes, and there are other alternatives as well. But this is what we used, and you can always use the Docker for the containerization, and you can give the idea here is the reason I'm showing this is. It is always good if you make it more open, flexible, and configurable, right? So that tomorrow, if client wants to run their application on, let us say, AWS or Azure or Google Cloud, if they want to run it on the TPU, GPU, it should be agnostic, platform agnostic, right? So you have to build the entire pipeline accordingly. That's what I wanted to convey here. And when it comes to, let us talk about, so far we spoke about the logo detection and two different ways of doing it. Let us talk about the various use cases, right? So first use case comes under marketing sector, which is sponsorship monitoring. So once you are able to do the brand identification or the brand visibility, what all we can do with it, right? So we can calculate based on the way or the place, or where the logo is present or the brand is present, and how prominent it looks. Based on that, you can always plan or tinker the sponsorship strategies you would have built, so that it is like a feedback loop, right? You plan for the sponsorship events, and you get the insights by running through the analytics engine, and then sorry and then you fine tune it so that you get better and better over a period of time. Of course, you can do, if the sponsorship is happening across, like let us say it is a like Olympic event, and you are doing sponsoring for the various different events and all, or it is a like a football league match spanning across a month and all, then of course day to day basis it can be a tight feedback loop where you constantly you are learning the things, and then like using it across the entire event. Even that way it can be done, and it can be used for the basically to measure the brand awareness, right? Where the actually brand is present. And also you can analyze the large scale events, right? Where, like, let us say, what I mean by that is large scale event. The thing with that is, because we spoke about whatever images I showed was something like, from a one camera footage. Large scale events will have, like, let us say 10 to 20 different camera footages, or sometimes it can be more as well, where the visibility from a given camera is different. Maybe it is the same match, but from different camera, one camera is more focused on the audience. Let us say one camera is more focused on the left side of the tennis court, and one is more of a, like, it shows the bigger picture of the tennis court, but the players are not clearly visible, and another one could be zoomed in version, things like that, right? So based on that, for each of that you can run through the analytics and find out the various components, like your visibility, prominence score, exposure time, and you can accordingly plan the future sponsorship deals. So the use case here is sponsorship monitoring. And actually the brand analytics or brand identification opens up to a lot of use cases in the retail and e-commerce sector. Because reason being, if you look at let us say you go to the superstore, or you are ordering online from the given e-commerce platforms, such as be it Amazon, Alibaba, platforms like this, right? There is a product image involved, and so a lot of the data, like I was talking about earlier, is present in the form of image and video. Maybe a person has written the review where he has taken the video of the entire usage of the product and all, right? So it opens up to the various possibilities. Along with that, let us say we are talking about the use case around the superstores, right? So if one wants to do the stock monitoring, right, on the shelf, let us say the company has kept the various categories of the products. Let us say we are talking about the water bottles. Then they want to understand, out of the 1 liter water bottle, 2 liter water bottle, half-liter water bottle, which one is getting sold more often, and which one needs more refilling, or which brand is doing well over the other brand. So there are like various possibilities around the stock monitoring, and you can use it for the product recognition, meaning which apart from finding out whether it is a water bottle or not, you can always find out which brand it belongs to by detecting the logo, right? So we'll talk about these a couple of the use cases in detail. And another use case is basically in media and advertising sector, where we talk about ad monitoring. Just like earlier we were talking about competitor analysis, here also you can do the competitor ad monitoring. And just like sponsorship ROI, you can find out, this is more like a in terms of brand analytics, it is mostly similar to that of the sponsorship, but just that it is applied to the different use case of the different industry. Okay. Okay, so first let's talk about briefly in detail about the sponsorship monitoring. Okay, so I think the details as such we have already discussed. So this is the image I wanted to show, where if you look at this particular image, you can notice that the various different ways the brands can be present, right? This is just I'm focusing on the background, and not even the this image doesn't have the camera view where it is zoomed in on the or focused on the players, right? Otherwise, even we are talking about jerseys, shoes, or the like caps and hats, right? So in this case, you can see like there is a Gulf, there is Xerox, there is a Toyota, City is there, Citibank. So there are these are the various ways, right? Budweiser is there. So brands want to understand whatever the sponsorship they are doing, or whatever the money they are investing, whether it is reaching the audience accordingly or not, or they are getting the right amount of ROI or not, or whether is it really working for them, making sense for them or not. So that is the whole intent here. And if you want to look at the sample output, to give you the glimpse of it, like let us say during the tennis match, you want to understand how the Kia brand fared, right? So for example, on the left side across these rows, you have the various different places, right? One is on the background, foreground, court side. This is what I mean by the placement or the position of the logo, because for the brand, they will have the associated brand value, or which can be translated to estimation value in, let us say for example, we are talking about dollar. If the brand is present on the hat, then what is its brand value? If it is present on the clock or the scoreboard, what is the value? So because they will accordingly know where they want it to be positioned, or the where they like the audience to see it, or because if it is on the scoreboard, then even if like let us say, even if someone is watching the entire event or not, but just once in a while looking at the scoreboard, then he always spots that brand, right? If it is on the, let us say, apparel, then only when I'm looking at the person or the looking at the match, at least for a good amount of time, then there is a more possibility for me to spot that brand. So considering that, and again for each of those places, you can see this is what I mean by the exposure time, which gives you, for example, on the scoreboard, it was a particular brand, which is Kia in this case, present for 15 seconds. On the court side, it was present for 3 minutes 40 seconds. So based on this, you can give the weightage, you can associate with the estimated value, and this kind of reports or the dashboard is what really as a once you're able to do the because logo detection is core part of it, then you have the analytics, and then you have these components, which is exposure time, brand footprint, and the placement, the clarity. Based on that, if you can correspond it to some business terms, or the business or the metric that makes sense for the business, then that's when they will be able to use it or apply it, right? So this is with respect to the sponsorship monitoring. If we want to talk about stock monitoring as a use case, right? So in terms of computer vision tasks, there are basically three tasks associated here. One is the detection of the product, which means you want to find out or detect can, bottle, or Tetra Pak present in the image. Second one is you want to classify it, which is a product recognition. You want to find out, is it basically a water bottle? Is it a milk bottle? What kind of product is it, right? And third one is brand identification. So again, in like water bottle, is it a Bisleri? Is it a Kinley? If it is a, like let us say, beer can, is it a Budweiser or some other brand? So this is the three different computer vision tasks that are needed, and logo detection is a part of it. And of course, as a part of if you build the so far whatever we discussed analytics engine, then you have access to all these three results, right? Because you are able to do the detection. Just that additionally, you will have to add the product categorization here. What I mean by that is, apart from finding out the where the logo is present and its coordinates, you will have to find out the entire or detect the entire object. In this case, let us say for example, can or water bottle, and its corresponding category, right? So that is the additional module or the task you will have to add to be able to do the stock monitoring. Okay, so for example, let us say we are talking about very small like superstores where they have these units or the storage units across placed across different places. Maybe brand will be interested to know, let us say there is a beer brand or the water bottle brand. They want to understand in terms of sales, the which unit is having more sales, let us say with respect to the time of the day, across the week, across the month. They want to understand, right? That's when, like, stock monitoring has a various use cases. In this way, one can use it to manage their shelf and manage the life of the product or the movement of the products across the shelves or the storage units. So you can always, for example, as an example, you can see on the right side, let us say one particular brand, we are talking about, let us say, Bisleri water bottle. What they want to understand is how many bottles are present in the given storage, and wherever the brand is visible, they want to understand whether it is a Bisleri or it belongs to some other brand, to be able to do the competitive and competitor analysis. So this gives the example of wherever it is marked in blue, it is like basically the brand was not visible. Wherever it is marked in orange, the brand was visible. Again, in that, you can always tell out of these 12 brand which brand it belongs to. That will be basically interested for that particular company. It will be like, metric of interest for that particular company. But if it is like, let us say, as a whole, I'm looking at a particular business, or I'm owner of a superstore, I'll be interested to know in general, even if I don't care about a particular brand, I want to know out of all this product, where there is a lot of movement, which requires proper positioning. Should I keep the cans at this particular place where it is easier for the users to take, or maybe it is better to keep it in the, like, outside of the superstore, because they need not enter the superstore to be able to pick this. So they can derive some these kind of patterns of the behaviors associated with the users. That is the whole funda here, right? And the third use case is, we spoke about stock monitoring, we spoke about sponsorship monitoring. Third use case is brand monitoring. So in today's world, we have so many various social media platforms. We have the streaming platforms such as, like, Netflix and all, and we have the various TV news channels, and we have the whole news and PR channel. So it happens across the various channels, right? Brand monitoring. Let us say I am Apple brand. I want to understand or monitor presence of my brand across various channels. Then I should be looking at social media, I should be looking at broadcast media, sorry, I should be looking at news and PR media. These are the various channels I should be looking at, right? Again, in social media, you of course have the YouTube, Facebook, Instagram, Twitter, various different platforms to look into. And in terms of computer vision tasks, right? So first, let us understand, like, for example, Instagram is more about, like, it is a image heavy, image and video heavy. Now you have the reels, and Twitter is more of a, like, of course, images can be present, but it is more to do with the text, what conveys the emotion or the sentiment behind that entire thing, be it for the political reason or the sports event and all. And YouTube, the creation and consumption is in the form of video. And Facebook, all these are combined, meaning the text, and video and image, right? So in terms of computer vision tasks, if I want to monitor my brand, so let us say the Apple brand, for the example, then I'll have to do the uh, logo detection, because that's how I can identify. Like, let us say there is a phone. If I find the logo of Apple, then only I can associate it, that, like, it belongs to the phone is iPhone and it belongs to the Apple brand, right? And of course, I have to do the object detection, because before the logo detection is the later part of it. First, to be able to do that, you will have to you should be able to detect the objects of your interest. Like, let us say you want to monitor the Apple brand across the wherever the phone is present in this use case, right? Like, let us say someone has captured the image, or taken a selfie standing in front of the mirror, then the logo is visible. First, you have to identify that the phone is present or object of interest is present or not. Then you identify or detect the logo. then you can associate it with a given brand. And wherever the text is present, you will have to do the text detection and processing, NLP task basically. Let us say, for example, I upload an image of the iPhone with a brief, like, 3-line review on the Twitter. Then to be able to monitor my brand's presence, then I'll have to do all of these three, right? I should be doing object detection, logo detection, to be able to identify the brand, and then process the text as well, because that's how I can, because the need as such, if we look at the need here, right, just like sponsorship event, if I am running the campaign, let us say I want to release the next variant of the phone or tablet belonging to the Apple brand, then I want to run some campaigns, right? So it really, if I look at all of these various channels, and if I run the analytics across all of this kind of multimedia data, text data, visual data, then I will be able to associate it with the customer sentiment. I can do customer sentiment analysis. I can spot the influencers who, then maybe I can have a tie up with them and ask them to, like, promote our products in a more better way. And I can, another use case is trademark and brand protection. Maybe there is a duplicate product, and once we are able to do the template matching with our original logo, we can find out, okay, there's a basically counterfeit incident of counterfeit here, and the company should take a notice of that. We can report such incidents. So as a need, you have all these use cases where you can plan for the campaigns and find out the like ROI behind it. We can analyze the customer sentiment. We can do the influencer spotting, and we can do the trademark and brand protection, like I explained. And this is just a sample, right? Like, let us say, through across the different days in a given week or a month, I want to identify on a Twitter, like, let us say this is for brand Head and Shoulders, right? We can, like, always find out the, like, how many impressions, how many times the word was used or people spoke about it. And out of that, if we are talking about visual data, we can really find out how many instances people really uploaded or used the data in the visual form. And we can find out the customer sentiment behind it, and we can always tell, was it a positive one, negative one, and build the correlation between wherever it says positive and what kind of image it had, when it is negative, what kind of image it had, right? And also the text mentions behind it. And let us say, if we are talking about Twitter and Instagram, we can also look at the hashtags or the, like, where a particular thing is trending. So there are, in this way, there are various ways, like compared to the stock monitoring and sponsorship monitoring, they were like computer vision heavy, mostly relied on the computer vision. But brand monitoring requires not just computer vision, you will have to do the NLP as well. But I just wanted to show and explain, like, in what all way, like, brand identification or logo detection helps you as well, right? So these three are the use cases that I wanted to talk about, where the brand identification really helps. Yeah, I think that's all from my end. I'd be more than happy to take any questions, or if you'd like to discuss on any topic, if you want me to, like, explain anything in detail, please let me know.
Yeah, hi. Thanks a lot, Venkatesh, for the detailed presentation. I think it was a fairly exhaustive one. I I had a couple of questions that one of them was mostly around deploying AI on the edge, especially when you're dealing with camera systems and all. So what were some
Hmm,
of the challenges that you faced, and how did you encounter them? Anyway, I mean,
sure.
in
Hmm,
the industry, deployment is a challenge, and
yeah,
maybe edge is like even a step further. So yeah.
yeah. Yeah, sure. So, yeah, I'll take that question, but not, it is the reason I didn't focus on that particular part is for this use cases of the brand analytics, right? It is not mostly relevant. Reason being, whoever is looking at doing something like this, they are more than happy to do it on the cloud because use cases like that, because the data is mostly available, like let us say in the form of a stream from the event or in the form of images and all. Maybe it is lying in the somewhere on the, say for example, AWS bucket or somewhere on the Azure, things like that. So uh, most of the people or the companies clients we have spoken to, they were all like, at least for these use cases, more than happy to run it on the cloud. But let us say there is a tomorrow use case for different problem statements or the projects, we face those challenges, which I'll talk about, because that will be, I think, really helpful for the community. So if someone wants to run it on the edge, right, so some of the challenges will be, of course, with respect to, first you will have to find out the memory and the compute power of that particular device. If the device is really, like let us say, portable device, right, the portable device can be like, let us say I'm talking about something like a GoPro is a portable device, right? So if the device is something like that, then you will not have a luxury with huge amount of memory and compute power. Of course there is evolution in terms of technology and all that, but it is not like whatever to whatever extent you will be able to do the things on the cloud, you won't be able to do in a similar way as well. So for that, what you will have to do is, you will have to optimize your deep learning models. For that, there are various ways to do the optimization. You can do the quantization of the model, you can do the pruning of the models, and for example, for any of these operations, floating point 32 is what we use, meaning each of my pixels is, let us say, floating point 32, and 32-bit is what I mean, which is like a 4 byte. Instead, we can always, without losing too much on the accuracy or performance, we can always use 8-bit as well. If it is really a challenge, then it will significantly increase the processing speed of the compute mind. And if we can optimize on the, like I was talking about, quantization and pruning, then it significantly reduces my model size so that I can easily fit it across various edge devices, like let us say the IP cameras or CCTV cameras. And even if some of the use cases can be like, let us say, there is a CCTV camera in, this is applicable for other problems, statements or the use cases. But just to give you the context or flavor of it, let us say there is a CCTV camera in the ATM machine, right? And there is a what people want to do is, if they want to do some processing on top of that, let us say for this use case, for some reason, people want to look at the presence of the brand on the various customers that walked into the ATM, is the one of the use case, let us say. So if the use case is something like that, then you have the stream from the CCTV camera. It is a old camera, let us say. It is not a new or intelligent camera where you have the software or the chip associated with it. It just gives you the raw image or the video data. What I mean by that, what people do is they basically set up one small board alongside it, and then they get the stream or the video data from the CCTV. But that particular board, if it has to be deployed in masses, like let us say I want to deploy it across all the ATMs in a given city or a given area in the city, then it has to be like optimal in terms of cost, right? I cannot use a given device that cost me thousands of dollars. I have to use something like, let us say, 30-40 dollars, then it is feasible for me. Then in that way, like, definitely optimizing on the memory front and compute power front always helps. And some use cases, for this use case, maybe real time output is not needed, because it is more of a, like, once you run through all this, for example, sponsorship event and all, once the event is done, they want to understand how it went and all. But someone wants to understand live, right? Then you will have to work on the compute power. That's when basically uh, running, like ensembling of the models or running the models in parallel or the distributed setup helps, if we are talking about the cloud. And if you are talking about the edge, then basically having, like, let us say, uh, what you can do is, whatever tasks it makes sense to do it on the edge you do it, and some of the heavier tasks which you don't do it often or doesn't require immediately or the live results, then you can always push it to the cloud if you have access to the, like, let us say, network or the internet. So there are various ways to go about it.
Okay, thanks for the detailed answer. I have a question around that is something that a community member also shared, is basically around using it on streaming data. Aren't there any? So how do you address privacy related challenges that may be involved, especially when the cases that you mentioned, like when you are processing, let's say the video feed of an
Huh,
ATM machine or something like that.
huh,
So how
huh.
do you address it?
Sorry, I didn't fully understand the question.
So how
Was
do
it
you
about
so
the real time related?
yes, 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 correct. So if you're
Okay.
using ML on a real-time data, how do you address
Hmm.
any privacy-related problem statements that may come from the business side? So because you're dealing with the images
Huh.
of individuals in that
Hmm.
case.
Hmm. So, see, usually it comes in two different ways. If someone has, usually what we do is, if someone has the data stored in their, say, database or container or in whatever cloud platform way, then they will basically have a strict restriction, like, you have to just take the data from that place only, and not allowed to, like, use it or push it at a different platforms. If that is the use case, so the way we would have built the engine is such a way that it can pull in the data or have the access to the data. Like I was talking about earlier, it should be agnostic to, like, when it comes to technology. I shouldn't build the analytics platform in such a way that I assume that my data is always in the AWS bucket, right? It should be more open, and usually it is more to do with the clients. It is like, meaning they will have the restriction on that. It is just that my tool, I should be more flexible to adopt it. That is one side of it. Another side is usually security related. If people have the issues, they will have it, because on the cloud it is like, as long as you take off a typical, like, you ensure that it is all encrypted and you follow some of the standard practices that are followed in the software engineering and data science. Nothing really, like, unusual. All the standard practices, it should be really fine. But on the edge, usually people will have these concerns, in the sense, they don't, when it gets challenging, I'll tell you, around this use case, maybe people uh, gives you access to the data on the edge device. But if you want to perform various different activities on the edge, but you know that one of the heavy activity cannot be performed on the edge, but it has to be pushed to the cloud, but they don't want you to take the data to the cloud. That's when it can get challenging. Then only way to do it is, like I was talking about, you will have to rely on the optimization of the models and whatever, because if there is a strict no from the client side, if they don't want you to take you to the cloud, so only in these two different ways we see restriction. If on the edge device, they will clearly say, like, uh, data or the images available to you on the edge, you can do whatever with it, but don't push it to, like, any network or the internet. So in these two ways, like, we can manage or handle it.
Okay, thanks. I have a question that I want to pick from Soumya. So first of all, she said thank you for the wonderful session, and then she has a doubt. She's a beginner in data science and knows a bit about NumPy, Pandas, scikit-learn, etc. Where can she learn computer vision with hands-on exercises and tasks? Could you provide a
Okay.
few references that you rely on generally?
Yes. Okay. So one of the, I think there are various resources, right, including the free ones that are available and even the paid ones. So some of the nice ones that I have come across is the computer vision course that is by Fast AI is a really good one. So I'm talking about, if you want to understand the concept of the theory, there are like a good number of resources available on the YouTube, or even there are good number of books, GitHub repos are there. But if you want to practically learn it by doing or the assignments, the Fast AI one is one of the a good one that I have come across. And even if you look at, if you want to learn it through the, let us say, for any given reason, if you are registered on any of these platforms such as Udemy, Udacity, or Coursera, there are a lot of good sources as well. But a good thing is, I think, the in today's world, the resource is, like, available in various different ways. But it is like, what matters is the path or the track you take it. So what I would suggest is don't directly jump onto. Of course, it is important to and essential to learn the things by doing and practical aspect, but it is essential to say, for example, what I want you to do is first understand the entire background and concepts of the statistics, algebra, and mathematics behind the data science and machine learning. Then jump onto the machine learning and data science course or the boot camp, whatever. These are just boot camps and courses. Trainings are different ways to learn it, but having a strong background in statistics, algebra, and mathematics really helps you to digest. Let us say tomorrow you are going through the course around convolutional neural networks, reinforcement learning, and all. You will be able to digest. So this is one important thing I just wanted to highlight.
Yeah, thanks for that. And also, a shameless plug here would be that you can also explore DeFi. It's again, yeah, it's also an open. No, but there are, I think, as you mentioned, there are a ton of open source resources out there. You can probably pick anyone that you, um,
Yeah,
uh,
the point was like including DeFi, right? In today's world, like, you will be more often than not, you will question what is the, if you have to pay for a particular course, you will think 10 times, not because of the money, but is it really necessary? Because so much of the content is made available by including like your platform, which is driven by like, a lot of enthusiastic people and industry leaders and all. So it is not just the quantity, even the quality is like, in terms of quality. Like if we look at, I briefly looked at like, some of the boot camps and the courses, but just that I haven't gone through in detail, so I thought you'll be talking about it, so just excuse me for
No,
that.
no, that's completely fine. Also, just to add to it, one of the things that I personally have felt on the free learning aspect is that on the learning front, if you are generally reliant on free resources, if you're a student more particularly, then you wouldn't, your learning would never be stopped. You can always find, you will have that habit of finding your ways to learn. If you are otherwise dependent on a particular platform, even if it is DeFi, you that may stop your growth at some point. So maybe just exploring continuously is a great way to go about it, something that I have personally come on to feel. Also, I was just very curious to understand on the answer that you lastly mentioned. You said that there are certain cases where the client may not want you to the processing must happen on the edge and not on the cloud or in a hybrid setup. So why is that? That is because of security measures, or what is the reason that
Yeah, so
you want
yeah,
it? Yeah.
yeah. So that is like not in the context of this, but for the entire data science or machine learning use case, this will be important to understand, I think. So one of the client we worked with, basically this is for the industrial use case. What we wanted to do was like detection and monitoring of the safety vias in the industrial setup, because industrial, these all big warehouses and factories in the industry setup, they have these areas where they work with very high temperatures. So by using computer vision, they wanted to understand whether, because there will be a supervisor to check whether you are wearing safety jackets, safety goggle, then safety boots and all. But if the supervisor is not around, you are not sure whether people are, because if they have been working for quite some time, then there is no, they may take it as very lightly, but you never know when there can be an accident, right? So considering this use case, they wanted us to build a computer vision safety gear detection. So in this case, they were more than happy to, like, they had the CCTV camera deployed, but for some reason, like, even if we follow all the like, security measures, protocols, their worry was like the image gives the inside of their industries, right? So they don't want like, just to,
Hmm.
it is like a just to be like foolproof or like 100% on the safer side. It was just their call, but they wanted to do it on the, apart from the edge, another option they give is like a local server. You can always set up a local server in this use case. Yeah, the good part about that question is, like, let us say you are finding it more challenging to do it on the edge, but you don't have option to go into the cloud. Another option can be set up a local server, like, you make use of the GPU, set up a local server. It is just a one time investment. And then, like, unlike cloud, because cloud is like a recurring cost, right? So even that is another way to go about it. Yeah, just as a use case, wanted to talk about that.
Okay, okay. Yeah, I think that was a very fair answer, and I did not even consider that as one of the reasons. I was just trying to guess what could be the potential reason to it. Yeah, that's a very fair
Yeah,
insight.
just to add one more point, in the industry there will be like SOPs, right? Let us say
Right.
there is a Tata's vehicle assembling plant. They
Hmm.
don't want someone not of their interest to look into how they do go about the processes and all. So there will be various places where they don't want in any way to leak the data. So yeah.
Mm-hmm. At times, one of the things that probably might also happen, I do not know, you can probably suggest is if the client is in an international geographic location, they may want the data center to be within their geography instead of
Yeah,
being in
yeah,
some
yeah,
other.
yeah. We have seen that always, especially with the if their even if their data is in the present in the AWS bucket, we have seen they want us to use Mumbai region, they want us to use Singapore region. That always happens. Yeah.
Hmm. Okay. Um, okay. I think we are done with the questions here. This was a very, very insightful presentation that you made. I think, and I had a few questions that I wanted to ask, but then you answered that as we progress in the presentation. So thank you for putting such a thought through, session for the community. We are very much thankful to you for being with us today. And I'm not sure, I really hope you enjoyed this because the community did. So thank you so much,
Yes, yes.
Venkatesh, for
Yeah,
being
yeah.
with us.
I'm yeah, always happy to do and to be part of something like this. Thanks. Thanks a lot.
Thank you so much. Thank you, everyone. We also, as an exception, generally we do a session every Saturday. We have a session tomorrow. In case you would want to check it out, if you're watching us on LinkedIn, go to LinkedIn events. If you're watching us on YouTube, you can go there, go and explore, find that session. You can also visit defi.tech/live sessions. Okay, that's another area where you can find a ton of resources. We are also starting off with boot camps. A very quick nudge there, because if you are somebody who's looking for a structured pathway, all of DeFi's resources are free, including these boot camps. The key advantage there is that they are very much intensive and community led. So you would enjoy learning in that particular duration. So you can check out defi.dphi.tech /bootcamps. That is where you would find those resources. Thank you so much. This is Mudit signing off for the day. I'll be seeing you tomorrow. Take care till then. Bye.